Thank you for attending our invitation. ACIS welcomes you to this virtual and the virtual participants also to our virtual colloquium cycle 2019 titled Showing Transatlantic Reciprocities Between Academia and Society. ACIS, the Colombian Association of Researchers in Switzerland, is a non-profit organization founded in 1992, established by researchers and professionals of any nationality who are interested in the Swiss-Colombian academic cooperation in all research areas. Our association seeks to promote the scientific, technological, and the development of Colombia, as well as facilitate the exchange and dissemination of knowledge and generate spaces for social exchange among our members. We do start today our colloquium cycle, which will include 3 seminaries in the topics of technology and society, which is today, migration challenges and perspective in November 21, and water resources and climate change adaptation in December 11. These topics are relevant in both context and worldwide. We would like now to thank the ETH for supporting us with these physical and virtual spaces. And we also thank the Javeriana, the Pontificia Universidad Javeriana of Bogota for the participation of our colleagues during the 3 seminars. As a brief introduction to technology and society, we all know that the development and the demand of communication and information technologies, CIT, have exponentially increased during the last years, and that this growth will continue over time. We are part of the modern society, which has been deeply influenced by technology, and we have evidenced several changes in our society, important impacts on our environment and natural resources, and notable effects in the economic dynamics worldwide. But of course, there are many issues, many problems, but also a lot of advantages and opportunities to use technology to improve in many practical ways our life, such as this virtual face-to-face meeting for sharing knowledge and ideas today. Our guests will give us elements to come up with an holistic understanding of the relationships between technology and society and how this relationship has influenced design sciences. They will share with us some examples of how engineers and professionals in general can develop technologies through involving social systems and preventing environmental negative impacts. The structure of the seminar will have 2 presentations, each of 25-30 minutes. After the second presentation, we will have time for answer some questions of the participants. First presentation is Sociotechnical Systems, Sociomateriality, and Singularity. The presenter is Professor Rafael Gonzalez Rivera. He is full-time professor in the Department of Systems Engineering of the Pontificia Universidad Javeriana in Bogota, Colombia. He has a degree of PhD Engineering and Information Systems and Simulation, and also a master's degree in Computer Sciences, both in Delft University of Technology in Netherlands. He is also systems engineer from the Pontificia Universidad Javeriana in Colombia. His main topics are software engineering, information systems, computer science, knowledge management, and computer and society. And their main projects are RED, FEE, Ibero-American Heritage Network, Knowledge Management System, and GAT, Alternative Cancer Treatment Program Collaborative Research Platform. So thank you, Professor Rafael, and the floor is yours.
Hello, hey everyone. Thank you for inviting me. Thank you, Sandra, for your pleasant introduction. I would like to apologize beforehand in case there is some background noise because we are having some construction work going on. Also, if you see that I have some issues with the connection, just let me know. I will turn off my video. That might help. Can you listen correctly?
Yes.
Okay. So what I'm going to talk about is briefly, yes?
Yes, it's okay.
Okay, I'm going to talk about briefly how I understand the development of the relationship between technology and society, particularly from my point of view, which is ICT and society. It's a long history. It's a very complex, conceptually speaking, so I won't go into full depth. It's just to give you an overview. You might be familiar with some of these theories or approaches, and I will focus on the central one, which is sociomateriality, and I will present a case. I have Nestor here with me. He's a PhD student of mine. So actually it's not my case, it's his case, which is the heritage domain. And then as Sandra mentioned, there is a second case, which we are working on right now, which is on collaborative science from a social material perspective. And then how that social materiality is leading into what some people call singularity, or that might be linked to what some people call singularity and what that might offer for the near future. So what is sociotechnicality? We might see it as a progression from early 80s when computers were being adopted mostly by people at home and at the office. So this created not only a technological revolution, but also a social and cultural revolution. And that meant that people had to start thinking about technology differently, specifically IT differently. Initially, we could take as the starting point the 1980s, although of course the story is older than that, as we will see. But in the 1980s, the idea was, okay, technology is not deterministic. That means it's not sufficient just to plug in some system, some software, or some hardware to obtain a result. In order for that technology to work, it needs to be articulated to the people that are using it, to the people that are designing it, to the people that are deploying it, to the people that are managing it, to the people that are supporting it, and to the people that might not even be using it, but that might be positively or negatively affected by that technology. And in order to figure out that relationship between IT and people, a third component is absolutely necessary, which is the organization. It doesn't have to be a company, but it's just the context into which that relationship between IT and people is being put into action. And in the 80s, this developed into the sociotechnical approach, although again, it's older than that. And the idea was, how can we make IT better for business? How can we improve the results of IT in companies, in firms, in communities? And this stemmed a little bit from a dissatisfaction about the actual results of IT. And this has not improved, I'm afraid, since the 1980s. Several surveys have continually been done about the success or not of information systems and IT in organizations. And consistently, it remains the fact that most IT systems are actually underperforming. That's what some people call the IT productivity paradox. And the paradox is, well, you're saying that if I use IT, I will gain more competitiveness or I will be more operationally efficient. But when I go and look at it, the project cost more than we expected. It took longer than we expected. And in the end, it didn't provide the results that we expected. And yet we keep buying and introducing new technologies. So some people are indeed getting fantastic results from technology. And the point was, okay, then it can't depend on technology. How come some companies succeed with the technology and another company will might be out of the business just for using that same technology? So it's not the technology, again, it's the relationship between technology, people, and organization. And as people started adopting these new technologies, the relationship became much more intimate. So we go into what we're currently in right now, which is a socio-material perspective, in which it's no longer an interrelationship between IT and people. What we're saying is technology and people are co-evolving, and the organization is co-evolving as a result of that relationship between IT and people. And this is also a result of technology being used not only for business purposes, but we are all carrying technology in our pockets right now. Not just one technology, maybe several technologies. We are surrounded by technology. So it became an issue of using IT not just for business purposes, but also for private purposes. And how do you align those different purposes? And again, how do you prevent the paradox from popping up? Because it's also presenting itself in the private realm, in the sense that I might be using, let's say, WhatsApp for communicating with my family, great. But if that means that I will be communicating with my boss also on Sundays, then that's not so great. So the same technology can have different effects, and it affects the way we relate to organizations, and it affects the way we relate to other people. So it's no longer a matter of considering society and technology as interrelated, but it's much more radical. It's considering sociomateriality as let's say a network or a configuration in which you can no longer separate IT from people and organization. They are completely intermingled. And since this tendency doesn't seem to be slowing down, but rather speeding up, it's leading to what some people, specifically Ray Kurzweil, already regarded as the singularity. And the singularity will be that point in which IT, people, and organization are so interrelated that they become as if they were a single entity. And that entity might make it difficult to recognize where people stop and technology starts, where the relationships between people are technology, and what indeed it means to be human in that new scenario of technology-mediated interaction. So some people relate that to transhumanism or transhumanity, or post-humanism or humanity, or super-humanity. Some call it the digital Gaia, as a single organism in which we are all connected through technology, and there is a single collective mind that is impossible to separate our decisions from the decisions that are going on elsewhere in the world. And of course, this has been going on for some time now. It's just a matter of it being intensified. So that's basically the story, but I will go into a little bit of detail. Sociotechnical systems regard society and technology as interrelated again. And this, one of the principal theorists initially, which is earlier than the 80s actually, she comes from the 70s. It's definitely a sociotechnical approach, but it's oriented to what most interests me, which is, okay, now I understand the relationship between IT and people and organization, but so what? The point is, how do we turn this not just into a conceptual tool to understand the phenomenon, but more importantly, a tool to intervene the phenomenon. So how do we design from a sociotechnical perspective? And that was Mumford's plan, that was her project. How do we design in a way which recognizes that sociotechnicality? And you will see that actually, even if this comes from the 70s, I believe that her project is unfinished, and it might still be relevant for sociomateriality and singularity itself. So some of the principles she talked about was ethical design. She said it's not about improving business, it's about improving the quality of life of everyone. Specifically, she was interested in the employees. She also came from sociotechnical theory, which comes from the social sciences, regardless of whether it's IT or not. But here the point is, of course, if you're using socio-technical theory, then you must put an emphasis in participation. You cannot design technology without having society participate in that design. It also was anchored in general systems theory. So the idea was to recognize the complexity of this phenomenon and use a holistic understanding of that phenomenon. And it was also related to the nascent methodologies related to action research, which was, okay, let's do ethnography, but let's do it in a way that we can also intervene in the system. And as we do it, we can create theory that results from that intervention. But she pointed out some challenges. She said, of course, doing this is not easy. It might be more costly to do it in a participative, holistic way. It's also utopian in the sense that it should be open-ended. You will never fully reach the objective that you're reaching, because as you intervene the system, you will change the relationship between IT and people. And so what will happen is that simply you will take it to a next level in which you can also do improvements. So it's not a traditional systems engineering approach where you solve a problem by providing alternatives, but once you've provided an alternative, it becomes another problem. And another difficulty is that since these are wicked problems, these are ill-structured problems, there shouldn't be one single method to approach them. There are varied methods to approach it. She pointed out that it should be, in any case, goal-oriented and adaptive. So that's a characteristic of socio-technical systems. They are goal-oriented, but those goals are changing in time. They are made up also of socio-technical subsystems. There is a possibility of doing things differently to reach the same end. So it's a design problem. Performance means not just optimization of the technical aspects of the system, but also of the social aspects of the system. And as a consequence, that means that we use human, social, organizational, and technical factors. And keep in mind that for the socio-technical approach, they are indeed factors. So they are related, but they are still, in a way, conceptually separate. So basically, that turned into an approach which said, okay, now we no longer just do the technical design, but we need to, in parallel, do social design. So you start defining social objectives on one hand, technical objectives on the other hand. You specify alternatives for each, and then just follow a typical approach where you, after combining them, prioritize and look at what your restrictions are, and then select the best alternative. So it was still very much anchored in the systems engineering tradition, in the traditional problem-solving way of doing things. There was one particular theory that came out from this socio-technical approach, which is Orlikowski's technology in practice. And this was stemming from Anthony Giddens' structuration theory. What she said was, when we use technology, we're doing it in a continued and situated way, which means that for one company, it's one thing, for another company, it's a different thing. But also for me, in the morning, it's one thing, and in the afternoon, it's another thing. When I'm in the office, I use technology in one way. When I'm in the transport system, I use it differently. When I'm traveling, I use it differently. So it's always different appropriations or different enactments, as she calls it, of technology. And as we start enacting that technology, some things starts to emerge. So actual architectures and infrastructures and installations emerge, but also norms for understanding such technology and using such technology start emerging. So you understand that, for instance, you cannot send an email with the same style that you send a WhatsApp. You use different language, you use different codes, and that also gives rise to different interpretation schemas, different assumptions of what is expected through those different channels. And this is what she calls, or actually Giddens calls, agency. It's not intent, it's agency in the way that it could even imply non-human actors as well. And when those different agencies start interacting, that's when technology in practice appears. But it's not just one technology in practice. Like I said, it could be several different structures that are emerging in parallel. So the point is not only that these start emerging, but as they emerge, they also influence future agencies. So once a structure starts to solidify, even though it never fully stabilizes, it does influence, and that's why the arrow goes both ways, it does influence future agency in the system. And as a result of that, she said, well, then a designer should consider that technology should and could be used in unintended ways. And unintended doesn't necessarily mean undesired. It's unintended, but it might be useful. So some people might develop apps, for instance, now that it's getting colder in Switzerland, you can download an app and then turn your cell phone into a hand warmer. The hashtag in Twitter was not created by Twitter, it was created by communities of users. But as a result of the users starting to use the hashtag, then Twitter changed its own API, it's changed its architecture, it changed its services. So it should be embraced rather than prevented that users use technology in unintended ways. And she also said, let's distinguish between different types of enactment. How far do you want to go with the technology? You might go into a scenario where simply you are reinforcing the current status quo. So you go and ask, what are you doing? I'm doing ABC, so I will develop technology that will help you with ABC. If it's application, you want to enhance that status quo. So you say, okay, you did ABC. Now with technology, you can skip B and go directly to C. Or you can do change, which is now what people call digital transformation, in which you say, okay, you were doing A, B, and C with technology. What you should be doing is D. And this has some design implications. Again, it's participation. And here there are a couple of principles. It's not just about doing it because it's the right thing to do, which is the moral proposition, but it's also a pragmatic proposition because it's evidenced through different studies that if you do it in such a way, the chances of success or the productivity paradox won't happen as much if it's participatory. And the role for the designer is that no longer you come in with the solution in which you are an expert, but rather you're a facilitator for that process of reconstituting technology in different cases and scenarios through time and through different contexts. So that's basically the tradition of socio-technical systems, which evolved into sociomateriality, or rather also came joined with other theories that were being developed in the social sciences in different fields. So here, the focus is not so much why technology works or what are the factors that make it work, but how does that actually come to happen? Why is not so important. It's understanding the process by which people become articulated to a technology. And so this is actually related to an older theory, which is actor network theory, in which that tradition even says actors are their network. Whatever you are being able to do in one point in time is always related to the network of artifacts and affordances that are at your disposal. And that is also not just connected to technologies, but to the materials that are around you. So sometimes, even though we can use a technology, we can choose to use a blackboard, we can choose to have a conversation, we can use to have a big red button instead of having some new mobile app. So it's opening up the possibilities of design, not just focused on IT, but on the whole network of materialities that are available or that might become available to a specific group of people. Barad, which was a feminist researcher, said, so how do we go about doing this in practice? She said, then it's not really about reflection, it should be about diffraction. And what she meant by this is when you see light reflected, it comes back. But when you see light diffracted, it comes back in a spectrum. So you can actually find out some things that break up light momentarily through diffraction, but don't change the phenomenon of light. What she's getting at is, even though sociomateriality means that social and material are inseparable, we can momentarily diffract that phenomenon and start seeing where the social is, where the material is, what materialities are there, and try to follow materialities as a way of understanding the system. So in the context, for instance, of health information systems, you might want to follow a specific medical device to understand how the network operates. But that means that it's usually meant to understand the system. It's seldom used to design systems. And this is mostly because it isn't even clear how to approach social materiality. Some people say that it should be radically social material, and in that sense, the material and the social are simply inseparable. And that means that ontologically or semiotically, you cannot separate subject from object. What you focus is on the relationship between the subject and the object. But others say, well, how do I actually do that in practice? When I'm coding my data, when I'm coding my research, I'm always classifying, I'm always separating, I'm using taxonomies. So critical realism offers a way in which we can do that as, again, like I said before, a provisional separation. You recognize that these things are entangled and you recognize that they are inseparable, but at some point you need to do an academic study or you need to do a design in which provisionally separating them is necessary to understand and intervene the system. So some of the design implications that come from this are that whenever you're designing such a system, transparency in interaction is very important. So this is linked to, for instance, tangible interactions. That means using your hands, using your body to interact with the system in a natural way for us humans. It means ad hoc design because it should be creative in the sense that it's not predetermined. It means that it opens up possibilities, but it's also a recognition that once you open up a possibility, you're usually closing up another one. So it has ethical implications. It's a recognition that failure is not inherent to the system, but it's actually how you perceive that failure, because maybe it's not actually a failure, it's not a bug, it might be a feature. So briefly, the case that we developed together with Nestor was on heritage, and here the problem with heritage or the scenario is that it is purely socio-material. So these people are intervening, for instance, an old church. So the material is the church itself, but it's also the materials that they are using to intervene the church. And it's also the materials that they are using to communicate about the project between themselves. So sometimes they will share documents, but they will also share photographs, but they will also share videos, and they will also share maps. And this is not only IT, it's a whole ecosystem of different materialities and affordances that come together. And then this creates a problem because they are not working alone. It's a heritage network of different countries. So how do we share lessons learned from the different projects, given that it's so complex? How do we just create a single document system to share our work, or how do we go about it? So the way we did it is Nestor developed a set of design principles. He said, again, design should be ad hoc, but that means that the system should be editable, it should be modular, it should allow for improvisation, it should allow for tracking the changes that have gone through the system, and it should allow persistence to get a memory of what has gone around that system through time. The second design principle is meta design, in the sense that you should be aware of the flexibility in your design. And that means allowing for definitions of granularity, but allowing also for space for action, so flexibility and openness, and interoperability in the sense that you're always able to integrate or pull out tools as the project and as the team changes. The third requirement is about exploring conversations or exploring coordination possibilities. So it's about tracing those different conversations and trying to figure out, why did you use sometimes Dropbox to communicate? Why did you use email sometimes? Why did you use the phone in others? Why did you use a meeting in others? And trying to uncover those principles of action in practice and recognizing how those decisions are made depending on the context. And then the final one is about, since we are sharing information, how do we go about sharing that information? And it's about making that knowledge visible. It's about allowing for customization of that knowledge so that I don't get simply access to everything, but only those things I need, which is also connected to filtering, specifically through tagging, enabled to evolve that filtering. Sometimes, depending on where I am and who I'm with, it will show me something, but if I change setting, it will show me something else. And as a result of those principles, he developed a system which is based on tools that are already existing. That was a principle that we wanted to favor, is let's not develop technologies, let's integrate technologies that are already out there. In this case, the Open Science Framework, which is a platform for open science or open research. Kumu, which is a tool for social network analysis and visualization. And Walami, which is it's a bit of a game, but it has, you will see that it has some nice applications with augmented reality. So first, the OSF allows us to share documents. It allows us to share different tools. So you can integrate OSF with Dropbox, you can integrate it with Zotero or Mendeley. So the whole team can share this in order to have the same documents, the same bibliographic information. And if you use Google Drive or you use Dropbox, then it's up to you. But we all centralize that through OSF. So OSF can connect with all kinds of different tools, and it's completely free, and it's guaranteed that it will continue to be completely free for at least 20 years or so. There is enough funding to support open, massive, collaborative science through this platform. And this is integrated to Kumu, which is the way in which they come into the system. So Kumu is also free as long as it's public. And what we have here is the network of people, but also documents and also projects that are related. And you can just navigate through through the different nodes in that network, and that will allow you to identify semantic relationships or collaborative relationships between the different elements that could be social material in nature. So it's not just digital documents, but also physical documents, and also the physical spaces that they are actually intervening. Everything is part of that network, and this links to the actual OSF space when they want to access actual documents. Now, if they go into the actual church itself, or whatever it is they're intervening, what we use is Walami. So Walami is an application. You install it in your phone, you use your camera, and then what you do is you graffiti onto the whatever it is you're looking at. And then if someone else is using Walami, you can share those scribbles, those annotations. You can have free annotations, you can add icons, you can add links, whatever you want. But they only activate when someone uses their camera to watch that. So if someone, an architect, comes in and says, remember that we need to paint this area, he will circle it, and then later on someone will come in and he will see the exact same circle by using this free app. Most people use this for, let's say, non-academic purposes, but then this is the use that we're using for Walami. And the last, just to finish, is singularity. It hasn't happened. Kurzweil anticipated that it would happen by 2045, but it's actually when we become something else, or when artificial intelligence becomes artificial general intelligence. So it's actually when it becomes like a human, and once it becomes like a human, then it can start replicating itself, and it can start making decisions, it can start participating in the design. So what does that imply with the relationship between socio-technical systems and design? So some people have said that this is related to other, let's say, tendencies in not just socio-technical systems, but also cognition and the way we relate to the world. And it's related to 4 E's. The first one is that it's about being embodied. And that means that all social interaction is always embodied. And that's always been kind of one of the challenges for artificial intelligence, in the sense that an artificial intelligence does not have a body, but we do. And so the mind here is related to the body, it's related to how we move, it's related to how we express ourselves, where we are standing, how we are standing, etc. And it's not just the body, but it's also embodied in the network of artifacts that are surrounding the body. So it's different tools, different technologies that we use as part of the way we interact with each other. And so what technology does in this sense is it enhances our space of affordances. An affordance is basically something that we can do with a specific tool or with a specific artifact. So with an embodied perspective, we open up that space of affordances and figure out that it's not just about IT, but it could be about the whole network of interaction. It's also embedded in the way that it's situated. The way we make decisions, the way we interact always depends on the context. It's reflective consciousness, but it's a reflective consciousness that is embedded into a pragmatically contextualized situation. So that means that consciousness and the way that we make decisions is not just pure, but it's also depending on the pragmatic situation in which we are in at some point. That means that it's actually through action that we go about cognition. So that means that going into singularity should highlight that pragmatic or action-oriented aspect of interaction. And that means that technology should then be developed with socially embedded practices. We are always developing technology using metaphors from our hands, like touch, screens. It's always related to our five senses, but also the way we communicate with each other becomes the cultural way in which we use metaphors to design technology. It's also inactive because cognition is not in the brain, it's not in the body, it's not out there either. Cognition happens actually when the brain interacts with the body and the environment. And as such, we cannot speak of a world that is given, but it's actually a world that emerges from that cognition and action. And that means that meaning is acquired through that action, not through representation. And this is critical in development of IT and artificial intelligence in particular, because representation was the dominating way of going about designing systems before. And it means I'm going to build a model, I'm going to build an entity relationship, I'm going to build a database that represents the world. We're not trying to represent the world in a singularity perspective. What we're trying to do is act upon that world, and that's what creates meaning. It's not the representation. And that means, of course, that cognition is not just the representation. That means that in order for it to be actually human or human-like, it should include affective and autonomic aspects of the body. And so this is, of course, a result of new research in cognitive science or in experimental psychology. Things such as our emotional state will lead us to make some decisions or others in a specific way, but it also might be unconscious autonomic aspects of the body. There's an interesting example where you're able to classify people as either cold or warm when you meet them. You say, okay, this person is warm, and I sympathize with that person, or it's rather cold and distant. Well, if you're holding a glass of cold water in your hand, you are more likely to judge someone as cold. So it means that it's directly related to our body. How would an artificial intelligence go about making such decisions? So it's a lot of open questions, but there are already some pointers or some ideas of how this could lead to new design implications. It's also related to the final E, which is extended. This comes from two different perspectives. One is the extended mind theory. Clark and Chalmers already in the 80s said that the mind is not in the brain. The mind physically extends into the artifacts through which we interact. So in some scenarios, a notebook could replace my memory, and as such, a notebook could be part of my mind. And if that is the case, some people have led into more radical extended mind theory versions, which is a transcranial or collective mind. If I'm extending my mind into a notebook, well, what if I extend my mind into the internet? Then my mind would be simply in the internet, and what we have is a transcranial or a collective mind, which is actually what singularity is is all about. It's a collective or transcranial mind. And it also implies that we identify ourselves with that technology. So it's again about an effective physical relationship we have with technology. And some of the design implications that emerge from that, I'm putting an image here of the new engineering building that we're having just a few meters from where we are right now. That's why I apologized in advance for the noise, because we're opening this new building in a couple of months already. And I put it here specifically because we're designing the building as a social material that would lead into a singularity type building, in which, of course, it should be smart, it should be integrated into the world, it should be integrated into our research practices. But it's not just the physical spaces, it's how we use them, it's how we design them, it's how we integrate it to the complete network of things that we're using both inside and outside that building. So the first implication is that we're no longer just challenging design as the relationship between what the system should do and what it actually does, but it's actually about challenging the assumptions. What that means is it's not just about feedback on how the system's objectives are being met, but it's about questioning, are you sure those should be the objectives that you should be meeting? For instance, some people are wondering about the future of artificial intelligence and whether this is a threat to human existence. And so as such, should artificial intelligence exhibit human values? And if it does, well, whose values? The values of 2020, the values of 1950, the values of 2045. And since they are changing, so this means that the values should not be embedded into the system. It's the evolution of the values that should be embedded into the system. And in order for that to work, then it should definitely have a lot of compassion. We're not sure how that would go about, but in the same way that us humans right now are compassionate, let's say, to non-human animals, then artificial intelligence should be developed in such a way that it's compassionate to us, non-artificial humans. And another design implication, which is the last one, is that of course we need to learn from these new crowd-based, collaborative, open crowdfunding, crowdsourced, crowd science perspectives, because indeed that is already a way in which humans are collaborating with technology and creating new knowledge together, which I believe is the key. I have more questions than answers, but of course I'm willing to discuss it in a bit. Thank you very much.
Thank you, Professor Rafael, for your inspiring presentation. Now we will have the second presentation, and maybe in the end, at the end, you can have some questions for both presenters. The next presentation is Batteryless Sensing Systems. Is presented by Dr. Andres Gomez. He works as embedded engineer in Miromico AG in Zürich. And he is a doctor of philosophy in electrical engineering and information technology from this university, the ETH in Zürich. And also he has a master's degree in embedded systems design in the Universidad de la Suiza-alemana, Lugano, Switzerland. And he is also electronics engineering and systems engineering from the Universidad de los Andes in Bogota, Colombia. His main topics are energy harvesting, cyber physical systems, and he is developing transient devices, cameras that execute image recognition algorithms and perform a lower power wireless transmission. So Dr. Gomez, the floor is yours.
Thank you, Sandra, for your introduction. And hello, everyone. All right, so good morning or good afternoon, everyone, depending on where you are. I would like to begin my presentation by asking you a question. Did you perhaps ever own one of these? This is the Nokia 1110. It was introduced in 2004, and you could use it for several days, maybe a week, depending on your usage. And you did this just from a small battery with 800 milliamp hours. So I owned one of these, and I used to enjoy very much not having to recharge it every day. But nowadays, maybe you have a cell phone that looks like this. This is the iPhone 11 Max Pro. It came out just a couple of months ago, I think. And even though the battery is around 5 times larger, the average use is maybe half a day, or maybe even less. It might even run out before the end of this talk. So if you look at the trend in general between the first cell phone on the left 15 years ago and the cell phone on the right, you generally see a functionality where, a trend that functionality increases, but you do this at a very heavy cost. You have to increase the battery size, which has a very deep and negative environmental impact. It's also much more costly, and the design of such systems is, in general, something that takes up a lot of energy and materials. So this concern is very important for engineers that design the next generation of digitalization, which relates to having sensors embedded everywhere in your environment so you can interact with them a little bit differently. So before I get into more technical details regarding electronic systems and electrical systems, I want to just give you a little interview into them because your background might be a little bit different. So the first thing that I want to talk about, you might see some numbers later on, it's the power. It's basically how fast you consume energy. And just to give you an idea, maybe you have some of these devices at home. If you have a water boiler, so to heat up some water, you'll consume 10,000 watts. This is just how much energy it consumes. If you have a washing machine that consumes around 1,000, and if you look at the general problem of having energy distributed to your houses, this is what you have an electrical grid for. In general, the engineering problem is that you have a certain load which has 2 peaks, one in the morning and one in the evening when people get up and get back from work. And so this dictates the load, how much energy the houses will consume. And the problem for engineers is to basically try to generate as much energy. And we try to avoid having deficits, because if you don't provide enough energy to the system crashes and you have a blackout. And if you're producing too much energy and then the houses don't consume enough energy, then you're just losing money because you're producing more energy and there is no efficient way of storing energy at a large scale. So this is the general problem for electrical engineers who design distribution lines, power lines, generation in a very large scale. And just to give you an idea of the type of devices that electronics engineers work with, it's way down, further down. So a cell phone, like the one that I mentioned before, it's something that consumes around 1 watt, 10 to the 0 watts. And if you have something like a smartwatch, a Fitbit, or something like this, it consumes 1 milliwatt. So there are many, many orders of magnitude between how much an appliance in your home consumes and how much a wearable device that you have consumes. And this is really where we want to go for embedding large amount of sensors in smart environments. So when you're in this very low power domain, you can power your devices with a small battery, or depending on the generation of the cell phone, how big the battery is. And generally here, the engineering problem is that you have a big battery that is charged from the beginning, and you just want to minimize your active cycles. You want to minimize how much energy you consume to do your different tasks, whether it's a phone call or showing the time, doing any type of computation. So here, just to emphasize, for battery-powered devices, the main goal is that you want your battery to live as long as possible. So for my PhD, part of what I still do at my current work is we try to design batteryless systems. And batteryless systems, as you can imagine, they're the most extreme end, the design end, in which your device cannot store any energy at all. So examples of this, these types of systems, I can mention, for example, the Micromote from Michigan. This is a small, I think it was even it had the world record for the smallest computer. up until recently. And you can see it fits within the edge of a coin. It's something that is just 1 cubic millimeter. There are other types of prototypes, so something slightly larger. This is a prototype from the University of Washington. And this is a device that was designed by the research group that I worked at here at ETH, and it sends BLE advertisings, which I'll get into a bit more detail later. So in general, these types of devices fit into the general category of cyber-physical systems, which are electronic devices that interact with the environment, but also interact with the digital world. So you can send information from the physical world to the cloud, to your cell phone, to any type of digital device. And so here you have this little cycle between observing things in the physical world, having them in the digital domain where you can interact with them from anywhere in the world, you can gain insights, and then you can feed that back through something called an actuator. You can influence your environment, you can turn off and turn on lights, change the temperature in a room. These are the types of systems that we talk about in cyber-physical systems. So for batteryless, what we try to do is we try to use the energy that is in the surrounding environment through something that's called a transducer. So in the system that you saw on the left, there's a tiny little solar panel that generates a very small amount of energy. With the system in the middle, you have an antenna there that converts energy from radio waves into electricity. And the system on the right, which I'll show in a little bit, it uses also a slightly larger solar panel than the system on the left. So now that I've introduced the general topics, let me tell you a little bit about myself. So my name is Andres Gomez, as Sandra mentioned. I'm originally from New York City, and as you might tell from my name, I do have Colombian heritage, first-generation American. As Sandra mentioned, I studied in Bogota, then I studied in Lugano, in Zurich, and I currently work at a design company where we design different types of systems that use low-power communication schemes to send data to very, very long distances, many kilometers, so we can cover an entire city with many different types of distributed sensors. So my talk will be slightly more technical. I won't get into many details, but I will focus on these types of digital devices and the types of applications that you can expect with this type of technology. So first, let me give you a little bit of an introduction into the core concept of batteryless sensing systems. Now, I should point out that if you go to a conference, an academic conference, and you ask 3 experts what they think a batteryless system is, you will get 4 different opinions. Right? This is something that is not an exact science. There are different types of opinions. I will show you my own definition. So to do this, I will give you an example of something that's called a BLE sensor node. So BLE stands for Bluetooth Low Energy. This is a very specific protocol that you have even on your cell phones. And it's just, so you see in the red area, you see 3 little peaks. That's the power consumption that goes up when you're transmitting a wireless packet. Right? So this is something that can be sent by a small device and received by your cell phone. So here I'm just measuring the power. So if you cannot see the y-axis, this is tens of milliwatts. So it's very close to the wearable domain that I mentioned earlier. And in these different phases, the different colors correlate to different phases. So in the first, the system puts up, it initializes, then it can read some sensor devices, something like measuring the temperature, the humidity, and the environment. And then you can send out, in the red phase, you can send out the information. And then it turns back off. This is the basic definition of what a BLE beacon does. It just turns on and emits a message. So if you do some highly accurate measurements, you take a look at this behavior and you see that it's very deterministic in terms of the amount of time that it takes and the amount of energy that it consumes. So basically, my definition of a batteryless system is something that stores just enough energy to be able to do its basic task. So in this particular case, for this BLE beacon, it needed 108 microjoules of energy. Microjoules is just the unit of how much energy it takes to execute a task. And so if we assumed that in the worst case scenario, you only get very little energy at a time, I came up with the definition of something that is battery-based and batteryless, which is based just on the amount of energy that the application needs. So if you have 110 microjoules, you do have enough energy at some point. Once your energy tank is full, you have enough energy to run your application and perform your task. But if you have more, so if you had a battery like in the iPhone, you have tens or hundreds of thousands of joules, that you could do this over and over again for many years. But the important thing for the definition of functional correctness is that you have enough energy to do just one of these things, just one measurement and one transmission. So this is sort of the threshold. Anything more than that is battery-based, and if you're just on the edge where you can do only one thing and one thing right, this is the biggest energy storage allowed for something to be batteryless. So this changes a bit the problem and the approach that we as engineers take to design these types of electronic systems. And I will explain this with an example between a battery-based system that, as I mentioned before, you try to design to live for as long as possible. So you do this with what I call the large energy cycle. And what this means was that you have an energy storage device, and you have empty on the left, right on the and you have full on the right, and you want these two things to be as separate as possible. Right? This is the trend that we talked about earlier. Cell phones have larger and larger batteries. And we do this because if we consume very little energy at a time, it will take a very long time for that storage device to empty. But if you look at it from a slightly different perspective, you'll also notice that the further away you put these two states, the harder it is to charge it back up to full. This is why you need to go in and stay plugged in for an hour or so while your device charges back up. So the new approach with batteryless sensing systems is not that a system should live for as long as possible, but that they should revive as quickly as possible. And to do this, we basically want to have the smallest energy cycle possible. So instead of having the empty and the full very far away, we want them to be very close together so that, yes, if you use it, it goes empty immediately. But if you have a little bit of energy from the environment, you can recharge it almost immediately. So the old approach to designing these types of systems is having sort of a predictable life. And this correlates a little bit to humans, that you deploy a device, it lives for, in the case of electronic devices, maybe 10 years, 5 years, more realistically, and then it dies, you need to change it and deploy a new device. In the case of batteryless systems, we don't have a predictable life because we don't know when it will end, but we have a resilient life, which is roughly like having a zombie that always dies, but as soon as there's a little bit of energy in the environment, it will come back to life and do what it needs to do. So even though we have these two types of approaches, we have to keep in mind that the different types of applications are, let's say that the bottom approach is not the right approach for any type of applications. There are only certain cases where they're really useful and they can save a lot of costs and avoid that very costly trend that we were seeing with cell phones. So the important, let's say, the best case scenario for batteryless sensing systems is when you have a correlation between primary energy and information. And this means that, so the information from the environment that you want to digitalize, you want to sense, it correlates with some sort of physical phenomena. And if you have this, that means that from this physical primary energy, you can generate electrical energy to power your devices and extract the information that you need. So there are multiple examples of this. The first one, and the one that, for example, Sandra had mentioned, was to work with cameras. Cameras are a very intuitive case because if you have some light can be used to generate electrical energy and power your little camera. But it's also important for the actual picture because when you don't have light, you cannot generate energy, but you can't take a picture. Or I should rephrase, you can take a picture, but if you have a black picture, you don't have any information in that picture. So here you have a very tight correlation between the availability of energy and the information that you're interested in. There are other examples. You can have, for example, vibration that is converted by something called a transducer called a piezoelectric. And this generates electricity from movement, which can also be tracked, which can also be used to track this movement. So there are different types of fitness trackers that can generate their own energy to track the movements from the user. And another example is to have a sort of device in the exhaust pipe of a car, of a normal combustion engine, that produces a lot of heat, and you can use this heat to generate electricity, and at the same time to read to have sensors read the carbon monoxide and particulate matter levels from the exhaust gas. So since I worked on the first case quite a bit, let me go a little bit into further detail regarding batteryless artificial intelligence. So very similar to the BLE beacon, what we do is just three simple things. We have a device that you see there on the right, and we have three tasks. So whenever the device turns on, it just takes a camera. It can run a special CNN algorithm that is trained to detect the number of people. And then once you determine the number of people in the image, you can transmit the results via BLE. So just to give you an overview of how this CNN works, you have something called a binary detector, which is, okay, I don't think you can, hopefully you can see it. It takes a patch of the image and it tries to answer the question, is there a head in this little box? And if the answer is yes, then it will classify that as there being a head. And you basically slide this binary detector over the entire image many times. And in the end, you're left with something like this. You have many overlapping boxes because the head was present in many of these little binary detectors. And then after you do this, you need to do something called non-maximal suppression, which basically takes boxes that overlap enough to count them as just one head. But it can be difficult when two heads are very close together, as you can see in this sample image right there in the middle. And at the end, then you just count the number of boxes that were left over. And this is how many classical algorithms work for detecting the number of people in images. So to do this, it's rather computationally intensive because we're using very small devices that consume very little power. In contrast, if you were to do it in your cell phone, which has much more processing capability, it's something that's done very, very quickly and without consuming that much energy. But for a small device like this, it is a very computationally intensive task. So I'm going to skip a little bit through the details, but in case you do have some background in engineering, I'll just give you a brief strokes of how we solved this problem. So the two basic approaches are to put all of these many computational tasks together and execute them all at once. This will be called a one-burst solution. The other extreme end is to have every single task executed by itself, but then you need to save into non-volatile memory so that you don't lose the state in between the different activity cycles. And from this, we can basically see that there are different types of trade-offs. The first one, you would need a very large energy cycle, so a larger battery or capacitor or energy storage to do your thing. And if you do the second approach, you'll have to write a lot of data to memory because you have many, many tasks. I mentioned in the previous slide, there were 5,000 tasks. So this would waste a lot of energy just moving data to your memory. So we come up with an optimization scheme, and I'm just going to briefly show what we did here in this slide. We used a special programming model to do some mathematical transformations to turn it into a graph problem, and then we used some classical algorithms to solve our graph problem. And then from this, we were able to determine the shortest path, which is basically the schedule that allows us to minimize the energy overhead for executing the entire application according to a boundary conditions. Right? That's the long, complicated mathematical version. But in the end, all you need to know is that it's optimized and that you get to have the least amount of overhead for running your application. So this this was part of the research that was done. I'm now going to talk very briefly about some other applications that you can find in industry, and you'll see some of them are a little bit more simplistic than the ones in research, because research topics need to have much more complexity. It's an interesting thing to see industry applications with batteryless monitoring that you would never be able to go to an academic conference for. And this one, for example, I'm going to mention is just to have to monitor lamps. So it turns out that there are many companies that need to maintain facilities, and they want to know when a light bulb needs to be changed. So the way it's done in many circumstances is to have people manually go around and check if their light's missing, or if it's something with public infrastructure, wait until a user reports it. So with a batteryless monitor, what you can do is you can just install a small little sensor device right next to the lamp, right next to where the bulb would be, and you would get this type of behavior whenever the lights are on or off, and usually these things have specific schedules. So when the light is on, the sensor will be powered automatically, and it will be able to send wireless packets to the cloud saying, okay, yes, I'm alive, which means the light is on. When let's say a street light is turned off, then nothing happens, and this is the advantage compared to a big battery-based device. If you had a battery-based device, you would always have to wake up and check, oh, okay, is the light on or is it off? Should it be on or should it be off? So with this type of minimized design, you automatically get the information you need when it works, because it should only work when you're interested in this specific case for the information. So you can use this type of behavior, this type of design, where you take advantage of the environment and the behavior that you expect from the environment to really minimize the costs for components, because you don't have to buy a battery, you can make your devices much smaller, you save some packaging, and it becomes much easier to maintain, because with batteries you at some point need to change them or recharge them, and this is very, very costly in real world scenarios. So the other thing that I want to mention with BLE beaconing is many applications in retail, for example, that can help you with indoor localization, because these short-range beacons can let your cell phone know, for example, that you're within a meter of a specific location. So if you're in a mall or within a store, you can really have digital information of where you are and what is around you. So to show some applications of this, I've taken some short videos from a company called Eyefinity, which is a Polish company. And I just want to then highlight the case of this BLE beaconing. This is in a museum, and a father comes to see a specific exhibition, a specific work with his daughter.
Now at Eyefinity, we can provide the knowledge that you need to bring out the magic hidden close by.
So basically, the guy just took out his cell phone, and because there is a BLE beacon in the work of art, the cell phone is able to recognize, yes, I am very close to this, and it is this specific piece, and it can even interact with it in case some type of interaction can be done. I'll now show another example from Eyefinity. This is in a hospital, and it also uses BLE beacons to advertise information related to the physical environment. I'm going to turn off the sound.
Our lives are filled with people who rely on us. Their sense of security is based on their need to communicate. Think about the Eyefinity world, where you have all the information you need to make the right decision.
So here, again, what was happening was the doctor was walking through different halls, and because there are beacons placed on that physical location, advertising information about who or what is in a specific room, he can see that directly on his screen. And then when he finally enters the room where the patient that he needs to visit, he can automatically get information wirelessly relating the vital signs or other specific information. So these are just some of the applications. Now I do have a demo prepared, and so it's not something related to the hospital. It's just that BLE sensor node that I had mentioned. It's something that is only a few square centimeters. It has different components, a microcontroller and a radio, and different types of sensors. And you will see that it's a BLE beacon that you can just place in many different places, and as long as there's some light around, they would be able to wake up, do some sort of interesting computation, and advertise that wirelessly. So to do this, I'm going to just mention something additional. I'm doing some measurements with something called a rocket logger. It's a device that I have here. It's a portable device. And if everything is well, I should, sorry, let me check something here. Can we switch maybe to the camera that we have here? Yes? Okay, great. So, okay, so here, what I have, I don't know if it's possible to zoom in. So here is the BLE device. It is connected to the rocket logger device here. And what we should be able to see in the application, actually, let me try to hold it up. We're basically just reading here. We're getting the temperature and the relative humidity measurements. And you can see that it's a counter that updates with each advertising that this is being sent. So here it tells me that the room is at 24.08 degrees. And if this should be working, okay, I'm not sure why it stopped working. This line that I'm showing back on the computer. Okay. So the cell phone is receiving new data, but okay, this one did not work. So with the rocket logger device, what I wanted to show you is that it is very environmentally dependent. So you can change so you can put more light on it, and the frequency with which beacons are sent goes up because it has much more energy, and then you can see this nice proportionality with the environment. All right, so unfortunately that didn't work, but the show must go on. So that's it from my side. Thank you very much for your attention, and I'll give the speaker back to Sandra.
Thank you, Dr. Andres, for sharing with us your interesting developments. Now we have 10 minutes to make some questions from the audience. Maybe you can start, Rafael.
I give you the.
You can. I think you can even.
Tell them. Okay. So my question
A little bit.
my question for Andres is, what is the environment effect from this batteryless system?
Okay, so the environmental effect is, so it's still, should I stand up here? Okay, I'll try to stand up. Okay, so the environmental effect is still there because we still have to mine some metals to produce some of the devices. And you do have certain aspects of electronic design that have some rare earth minerals, and this is, let's say, something that can cause some environmental damage. So unfortunately, we don't yet have a way to have zero environmental impact. The point of doing this is that you get to avoid the battery, and the battery itself is one of the most, I would say, one of the most harmful elements of having these small sensing devices. So it depends a lot on the chemistry that you're using, and there are obviously different technologies which have different trade-offs, but it is a very expensive part of the most expensive component in these types of systems. I'm not sure about the cell phone. In the cell phone, it might be something else. I think in an electric car, the battery is also one of the most expensive components. And so doing it in this way just helps reduce certain costs and makes, let's say, makes the service much more scalable. So what the trend that we had in cell phones, where we need bigger and bigger things, is just too costly. And we will not be able to have smart cities, smart infrastructure, smart homes, if we need to have bigger and bigger batteries as time goes on. So what we need is better transducers. We need better technology that does less with, so it does more with less energy. This we certainly need, but by cutting certain aspects of the harmful components that are needed for these devices to work, we lighten our load. So there's still some sort of impact anyway.
Okay, thank you. And now question for Professor Rafael.
So it was very interesting, Rafael. Thank you very much. I had a question about, so it's very interesting to talk about this movement toward the digital Gaia that you were talking. I was wondering, how do we address the potential inequalities that access to technology may create?
Did you get that?
I think there's a delay with that.
Yes, I understand. I'm just, I'm not sure I have an answer for that. The way that we have studied this before is mostly through an ICT for development perspective. And sadly, there has been a recognition that whenever you introduce a technology that is aimed to reduce inequality, you might be, in effect, creating new inequalities. So, for example, from the sociotechnical perspective, there was a lot of work, or there still is a lot of work on using ICT for development in rural areas, for example. And then what you have is some ideas on how to introduce technology that will enable people to get inserted into a global economy and have better information to manage their crops and have better information about market prices. So this reduces the inequality because it enables them to have much more leverage in the business. However, the side effect from doing these kinds of interventions is that once you introduce this technology, it will benefit some farmers, and those that do not have the technology will be excluded from this system. So it actually creates new inequalities. And there is no way to deal with this except for a different approach, which is sociotechnical in nature and which might begin to answer your question. And it's the concept of self-help groups. What that means is basically you change your unit of analysis. Rather than focusing on specific users, you focus on the community as the user of the technologies. You say, this is not a technology for the rice farmer, this is not a technology for the potato farmer, this is a technology for the community, regardless of whether they are farmers or there might be microfinancing involved, there might be other transportation services that develop around this ecosystem, and then you focus on the group. And that also creates a possibility for not dealing with the situation that people come in with different capacities to begin with. So some farmers will adopt the technology faster because they're already experienced with using cell phones, or they might have a better level of education, or they might be younger. So what you want to do is, rather than focus on these more likely adopters, turn them into, let's say, coordinators or facilitators for the group. So it's very simple things. Rather than having the app being used by individuals, you say, okay, the app is for the community. Maybe you identify 1 or 2 users which are more likely to be able to use it effectively, but these people would be intermediaries for others to access this technology. So for instance, an older farmer will have a younger son. The younger son is able to use the app, but it's not for him, it's for his father, or maybe it's for the whole family, or maybe it's for the whole community. And then that reduces the possibility of creating inequalities, but it doesn't eliminate it, because there might be a neighborhood, a different town nearby where that community is not there. But as you can expect, it's not simply a technical solution. It requires creating the actual social, let's say, social relationships in order for that to be successful. And that might mean an intervention on creating the actual groups before you come in with the technology, or at the same time as you develop the technology. That reduces the risk, but it doesn't completely eliminate it. And as we go into singularity, well, then it becomes really troublesome, in the sense that it's not just inequality between those that have the technology or the access of the technology and those who don't, but it's going to become inequality from the artificial intelligence that is able to solve problems without the humans, and the humans that might become obsolete. So again, the idea is not how do you level the playing field, but how do you improve the collaboration. So how do you integrate the artificial intelligence with humans, and how do you integrate humans with themselves? So in short, the answer is collaboration, but the actual trend seems to be that inequality is growing. So I'm not sure whether that is enough, or even whether it should be a design solution, or maybe it's an issue of revising our economic system, etc., which of course goes beyond my expertise. But I believe it's a critical question, because always people are being left out. But in the end, I think the emphasis is trying not to figure that this is let's say, digital divide, which is what people usually think it is. It's not a digital divide. Digital divide is simply a consequence or a symptom of a cultural, social, economic divide. And that's what we should be solving, and technology can help solve that, but it's not through technology that you solve that. I'll give you an example from Colombia. Colombia is always revising in each new government where to put the money in terms of reducing the technology divide. And I think that this is the wrong approach, because it's condemning us to always be behind. So for instance, a government comes in and says, oh, we're behind in broadband internet access, so we need more broadband internet access. So we need more, say, optic fiber going around the country, and now, okay, check, we have broadband internet access. But then you realize that people are using this broadband internet access now for cloud computing or cloud services. So you realize that the divide wasn't the broadband, it's the services that go through the broadband. So indeed, we are shortening the gap in terms of internet access, but it's widening very, very quickly in terms of cloud services. So if we play this game of catching up with the technology, we will always be behind. I believe it's not through technology that we solve these kinds of inequalities.
So that's super interesting, because that was my next question, actually. So from your perspective, do you think that given that we are moving into this era where human boundaries are not necessarily that clear anymore because of the integration with technology, do you think that Colombia is taking the right policy steps to address those new challenges? Or you think that, well, I guess you already gave me part of the answer, but yeah, I wanted to know what are your thoughts of how Colombia is doing in terms of technology policy.
I have mixed feelings about it, because I think that sometimes the intent is well intended. There are actually, we interact a lot with the Ministry of ICT, because we have a couple of centers of excellence operating here in the university, and they're always communicating with us about the strategic plans that the ministry has in terms of creating capacity, not just at the business level, but also at the citizen level. And we've discussed ways in which we can do this in a way that is sustainable. So one of the things we've said is instead of doing these cause that the ministry has been doing for a long time, like massified technology. So let's teach everyone how to create a web page. Let's teach everyone how to develop an app. And so at the beginning of this government, we were talking with the ministry and we said, well, this is not the right approach, because we're creating a lot of people that attend these seminars or short courses, but nothing really comes out of these courses. It's just a check for the government to say, now we have 1 million people that know how to develop apps, but it's not a real number. It doesn't really contribute to development. So say, okay, let's use this self-help group concept, and rather than focus on the individuals, let's create group capacities, because the idea is not that you're able to develop an app. The idea is that you're able to develop a company that builds apps, and that's a completely different way of going about it. And so we are working on this, but at the same time, just a few weeks ago, they came out with a program to teach people machine learning exactly the same way that they have done it with creating web pages, exactly the same way that they've done it with developing apps. So they assume that simply by teaching people how to use, I don't know, Watson, then all of a sudden we will have this capacity. So I think that even though there are good ideas, I'm afraid that sometimes decision-making is made somewhere else by someone else with some different criteria. I'm sure sometimes it's just two powerful people sitting in Miami and making the choice, regardless of the actual technicians and knowledgeable people that are building better solutions. So it's a bit of a tension, and the two things are going in parallel. But in short, I do not think that we're doing the right job right now, not enough. On the other hand, it's not just the government. So we see a lot of private initiatives and a lot of international companies that are starting up businesses here, virtual universities or different kinds of education systems that are meant to create capacities for these new 4.0 industry kind of technologies. Andrew Ng from Coursera opened up a company to, say, develop skills, but also try to provide machine learning and artificial intelligence services for the rest of the world. We have one of the World Economic Forum's centers for the fourth industrial revolution here in Medellin. So a lot of things are happening despite or in spite of the short-sightedness of the government, and those things are working, but the window of opportunity closes fast. So it might be that we do appropriate and grow out of this opportunity, but it might also be that we continue doing things the same way we've done it before, which is, okay, how do the Israelis do it? Let's try to copy that. How do the Indians do it? Let's try to copy that. And now I guess everyone is trying to do the Stanford way of doing things, so let's do that. But we need to figure out what it is to do that in our context. And I believe we're working towards that, but we shouldn't expect the government to do that. I'm not confident that they will do it.
Okay. Do you have another one?
I have more questions.
Do you have another one? No.
I want one
Maybe-
for Andres.
Okay.
Or do you want to?
No. Maybe this one and maybe another one and.
Okay, well, I have lots actually, but one for Andres. So Rafael was mentioning this push towards singularity and the digital Gaia. Do you actually feel, in your work, do you actually feel pressure to actually develop products towards that direction? Is this something that the sector is consciously doing, or is something that is just happening organically? Everyone is moving towards that. And I wonder, now that you made the transition to industry,
In the electronics industry, I would say no, you don't feel this pressure and towards, or let's say the march towards this singularity. But you do see it a bit more in informatics. So I was just last week at a conference, and I saw industrial conference, and I saw a presentation by Google. But you can see also in YouTube some presentation by Google where they show very advanced systems, in particular the Google virtual assistant, It's a device that you give it some instructions to your cell phone, and it will automatically make a phone call for you. So it will be a device that makes a phone call, interacts with other humans on the phone, makes reservations, and interacts with them in ways that you would only expect a human to do. So this, I think, goes towards that direction where your cell phone basically becomes your, or the term personal digital assistant will become more, let's say, more accurate, in which it will be literally your personal assistant, but it will be something digital. It will be a piece of software that can do many different things that you would not have expected a piece of software to do. So that, in that regard, you do see it more and more. But especially in low power things and electronics that are battery based, no, you're still light years away because it just takes too much energy. Let's say that's a restriction. But when you have big cloud services, there is where you definitely see this trend and overlapping things.
So your life story is very interesting, Andres. So you raised in the US, bachelor in Colombia, then moved to Europe. So it's very interesting because you have experienced many of these worlds of, now you're in a hub of innovation, let's say in Europe, within Europe itself. What do you think it could help Colombia to become an innovative country in terms of technology? Now you have different setups, the American system, the European system. You have lived in Colombia.
Yes, that's a difficult question. And in fact, so even as Rafael was saying that he wasn't sure, or he was talking about how other people have done it in other countries, in Israel, India, and Stanford. Well, it's not a country, but a different approach. And the Colombia needs to find its own way. And I completely agree. I just have no idea what it is. So when I was there, so as an adult, I lived a few years as a child, but for the most part, it was really just as an adult for college. And I can tell you, I had many, so culturally speaking, I was lost many times while I was there, and I had to go through an adaptation phase. And so even though I consider myself Colombian American, there are many things about Colombian culture that I don't understand, and that I don't even have. I don't understand. So I really don't know. But I can tell you this. I see, so during my time in Colombia, for my bachelor's, I saw many talented engineers. I really saw people who could do amazing things, especially because of the lack of resources. When you have a lack of resources, you need to be much more resourceful and much more creative with what you do. And I saw many solutions that, or let's say, at least at a technical level, they're just as advanced as you would see in anywhere in the world. And sometimes when you compare, when you have, let's say, in another type of country that has many more resources available, you see a different thinking that I personally, at a technical level, I would say is a little bit of a disadvantage, because they're used to things, having the full set of resources to address solutions with big systems and sort of have the intuitive, easy solution, oversimplifying things. And I personally, I wouldn't know what it is that for innovation, because it's not just a lack of resources. I mean, if you have the right idea, you will get the resources no matter where you are. I guess it's something a bit more, there has to be a certain change and a bit more in society. So some of the things that I definitely saw while living in Colombia, innovation, so let's say the mentality of what success means and how resources are invested are very different. People, even in university, when it comes Friday night, they thought more about where to go dancing and partying than to think about, what activities are they going to do the weekend, how are they going to make better use of their time. So to me, it's more at the societal level where there needs to be certain change before the country can use the resources that it already has effectively and, come up with their own solutions that are right for their context.
I have one last question, very
Yes,
quickly.
very
Can you just quickly say something?
Yes, sure, Rafael, yes, please.
Yeah, just I'd like to complement Andres's answer. I recently read a study. It's not just our lack of resources that makes us more creative. Apparently, it's our lack of respect for authority and rules. That also has its, wherever countries are more rule-abiding, they are less creative, and the other way around. So it's always kind of striking a balance is what is difficult. And the second issue is, again, I'd like to highlight collaboration. We have a center of excellence in big data and data analytics in Colombia. And if I were to group everyone that works on those topics at Javeriana, maybe I would, if I'm lucky, I would maybe get 30 people, 40 people, including PhD students. That's not enough. But if I join them together with Andes, EAFIT, ICESI, Javeriana at Cali, we have a group of 120 people. And so even if we are in some scenarios competing, which we are, in this specific scenario, we're collaborating and we're finding, and it's already been 3 years in which we have proven that this is the way to go forward. It's not by competing, but by collaborating. That's just my 2 cents.
My last question, and it's something just very short. It's probably the typical question you always get from your relatives. Yes, to both of you. What are the most exciting technological developments on our way? What are the game changers that you think, okay, this is gonna change things in the short and medium term?
Rafael, would you like to go first?
I'll just give you a short answer because it's not going to surprise you. I am absolutely convinced that it's artificial intelligence.
In the short term, yes, I do also agree. It's what you see everywhere, developing new applications, and big companies are investing large amounts of money to develop new services for this. In the longer run, though, I think something like quantum computing could be something that changes the way we do things significantly, because once we have enough power to perform massive computation very efficiently, then there are many applications in pharmaceutical things for very specific drugs. There are security concerns as well in terms of how you'll be able to do things securely. So I think the quantum computing, in a little bit further down the line, will have a potential to also have a huge impact.
All right.
Okay. Thank you, Rafael. Thank you, Andres, for your participation, and thank you also for you. And we are publishing, sharing this seminar soon with more people, and see you on November 21 in the next seminar about migration and challenges. Thank you very much.